Okay, we're going to use relative motion analysis in order to solve and figure out what the omega AB has to be if the velocity of this slider C is 4 feet per second. So again, what I basically have here is I'm going to look at member BC, because member BC is in general motion. AB is in pure rotation about A. C is in a vertical displacement. Okay, so basically I'm going to look at this rod right here, member BC. Now, here's what I know. I know the velocity at C is straight down at 4 feet per second because it's in that slider. That's given. Here's the other thing I know. I know that the velocity of B has to be perpendicular to my radius, again, or tangent to the path as AB goes around in a circle. So I know that is also down. And I know that it is R omega, where R is 2 times omega of AB. That's what I'm looking for. Again, that's the velocity of B is equal to 2 times omega AB. That's what I have here. So I have this velocity of 4, this velocity of 2 omega AB, and then I've got RC with respect to B and omega BC, and I'm going to use that in my relative motion equation, where the velocity of point C equals the velocity of point B plus omega cross R. Okay, so first things first, I can determine the position of C relative to B just by using the sine and cosine of 30. Okay, and again, it's C. That's a little typo. That should be C relative to B. So it's in the x direction 3 cosine 30, in the y direction 3 sine 30. Okay, I'm going to use that in this point right here. Okay, so again, VC is negative 4 down. So negative 4J. VB is negative 2 omega AB in the J. Okay. Omega, I don't know, but I definitely know it's in the K direction because it's a planar problem, so I can only rotate clockwise or counterclockwise in the K direction. Then I'm going to cross that with the relative position of C relative to B. Okay, so I have this two-dimensional equation. Okay, after I do the cross product, okay, I have 1.5 omega BC in the I direction, negative I direction, and then I have this negative 2 omega AB, as well as 2.598 times omega BC. The cross product to the K cross I gives me that. So I have some I components as well as J components. Okay, so when I sum up my I components in the X direction, all I have is 0 and the negative 1.5 omega BC. That means omega BC is actually 0. So I'm going to take that, plug it into this equation right here, okay, where I take negative 4J and then 2.598 times omega BC, which is 0, minus 2 omega AB. Solving for omega AB, I get 2 radians per second. So again, I apply my relative motion equation to the intermediate rod that is moving in general motion with some translation, some rotation. In fact, this one's not rotating, but that's just because of the specifics of the problem. At a different point in time, it would be translating as well as rotating. And then just putting in what I know about, certain points on the thing, such as the velocity here is 4 straight down, and I know the velocity here is perpendicular to the leg AB, so I put that in there. Plug it into the equation. I got X and Y components, split them out, and solve your problems.